Hello students. In this lab, digital signal processing lab, the first experiment is verification of sampling theorem. Before going to this experiment, first we will understand why we need sampling. That all the generally that signals are in analog in natures, but whatever the equipments we are using, that is in digital in natures. So we have to process that signals mean digital. Means if you are converting the analog signals to digital signals, that one we are calling as analog to digital converters. The analog to digital converters involves three steps: sampling, quantization, and coding. In one of the method is sampling, and hence we will discuss on how that sampling theorem will be work. The first of all, that main aim of the experiment is to sample the analog signals. First, we will understand what do you mean by that sampling process. It is a process by which continuous time signal is converted into discrete time signals. Next, sampling theorem, it states that band limit signals having no frequency component above the fmax in hertz means a sampling frequency is greater than or equals to 2 times of the input frequency. And here it is a program for sampling theorem, that f is input. Here the t stands for the signal time period between 0 to 0.1 steps. Here x in the sense we are taking the sine waveform or cosine waveforms. Here that cos 2 pi ft in the sense we are taking here cosine waveform. It is continuous time signals. We have to discrete this continuous time signal into digital signals. And here fs is our sampling frequency, ts is time for sampling. We know that t is equals to 1 over fs. Here the tn in the sense we are varying time in steps with respect to 0 to 0.1. tn stands for the discrete time signals. Next we have to plot the continuous time signals, discrete time signals. For that we are using that subplot in the sense it is containing the 3 window. In the 3 window, this one stands for the first row and this stands for first columns. Here the plot t versus x. T in the sense here t is our continuous time signal, x is our input cos 2 by ft. Next another one will be we are using that stem command in the sense it is a command. Here we are using to discrete that signal. Here the tn is discrete time, x1 is cos 2 by ftn. Next another plot we are taking with respect to tn and x1. Here we are reconstructing the waveform. Here it is MATLAB editor window. Here we can run the programs. We can type the programs. Now what I did in the sense I already copied that program here. We have to run that program. Okay. Here we have to assign the frequency. If I am assigning here 50. Next we have to give the sampling frequency. Already I explained that sampling frequency is greater than or equals to 2 times of f. So here I am giving the sense 100. Okay. This is our continuous time signal. This is our discrete time signal. This is our reconstructed waveform. Instead of giving the 2 times of the 50 hertz, for example, take it as more than 5 times or 10 times in the sense 500. So here we are giving the smooth waveform in reconstructed form. Thank you.